Okay, hi everybody. Welcome to the ONOS track. My name is Tomas Wachuska. I'm the chief architect for ONOS as well as one of its developers. And so I'm going to kick off today's this particular track with an update on ONOS, which is then going to be followed by Jordan's talk on how to distribute how to develop distributed applications on ONOS. Carmelo is going to join us later to talk about P4 runtime. Then Ray is going to provide an update on a new Bazel system that we put in place in the previous release, and then it's going to be followed by a half-hour break, and after which Sona update is going to be given by Jean, and an hour-long session provided by Jordan about distributed primitives and distributed development for ONOS. So let me kick that off with ONOS update. And the idea for this talk is basically to give you an idea for where ONOS has been, at least recently, within last year, kind of to give you a picture of where it is today and then where we intend to take it in the future. So I'm also hoping to leave some time at the end for questions, because I'm hoping there will be some. So in the last year, we've released actually 4 releases, which is normal, you would say, because we've released on 3-month cadence before, but we've actually switched to 4-month cadence with the 1.13 release, but we still released 4 versions, and I'll explain why that is. Now, rather than going into the details of what all of those releases were about, in summary, last year for ONOS could be described as being basically about stability, making sure that the ONOS has features in there to enter production deployments. So things like diagnostic, remote administration, improving REST APIs, fixing defects, adding integrations with Kubernetes, Helm charts, and things like that. Also, adding scalability optimizations into the platform to make sure that as we've entered to different production deployments, we discovered there were some inefficiencies, so we've eliminated those. Also, separated the ONOS cluster from Atomic's cluster, which is where the data is kept, and you'll hear more about that from Jordan. Did optimizations in distributed stores to remove inefficiencies and so forth. And overall, just generally reducing the technical debt that has, some of it has accumulated through the initial years of exuberance, where community was adding features and more rapid pace. So this was basically just to let the dust settle, make sure that we have a nice and stable platform to build on. So what I've described right now is just basically what the core team has been doing, and the ONOS community working with the core team has been doing. But of course, in the meantime, there was actually thriving development elsewhere. The community continued to add extensions and develop new features around the periphery of ONOS. So we now have 170 different applications which are actually part of ONOS, that are distributed as part of ONOS Tarball, that can be ignited on demand. New southbound APIs have started to be developed, building on GNMI, GNOI, and P4 runtime. And this will tie into the conversation that Carmelo will be having here. Also, we started to rewrite UI front end to rev it up to the latest UI technologies, because some of the building blocks that we've used are going to be deprecated, and we wanted to make sure we were not stuck in a land where ONOS had a defunct technology in place. And this is where I wanted to thank Sean Condon for doing an amazing job for driving that work pretty much single-handedly, in terms of both initiating it and executing it. So thanks, Sean. And also, last but not least, ONOS and Trellis application have entered production deployments in Comcast. Currently, actually, they're running on a year-old version of ONOS. 1.12.1 specifically, so it's actually slightly less than a year old, and they're upgrading, in process of upgrading to minor release 1.12.2, and they're evaluating 1.14, which is the August version of ONOS, to enter larger scale deployments. And so that's just where ONOS has been, at least up until August. But in August, and this is kind of starting to describe the current release, where we're still in the middle of this right now, the Peacock release, we've realized that Java 8, which is a long-term support release, is going to reach obsolescence, and that Java 11 was actually going to be released. It was released in September as a next long-term support release. And so what we plan to do is we plan to upgrade to that, and we also, associated with that, we had to upgrade to ONOS, the Apache Karaf underlying ONOS as well. Because actually prior to 4.2.1, which also released in September, we wouldn't have been able to do that. Karaf actually didn't support that. So it ended up being a kind of a perfect confluence, perfect timing for us to be able to do this work, to kind of leap on a new plateau of stability, because Apache Karaf team is working feverishly on 4.2. Java came together, and so now ONOS is basically completely caught up with the latest platform of Apache and platform of Java. And so that leaves us nicely set for a couple of years. We should be able to cruise on this platform. So that was kind of the objective of the Peacock release. But as we embarked on this journey, we quickly realized, as part of doing the Apache 2 work, that there was going to be some backwards incompatibilities introduced, and that was simply out of our hands, because the way Apache Karaf decided to use standard OSGI annotations rather than Felix annotations, as has been the case in the past. So basically moving things more towards a standard. But that entailed making changes to ONOS and also any applications that were to be deployed on ONOS in order for them to work. So basically break in backwards compatibility. So while we don't like to do that, this was kind of forced on us, and I think it was well worth the cost. And because of this, we had to basically decide to make the major version of ONOS 2.0. So ONOS 2.0 is basically just the same architecture, just a new platform, business as usual, but just with the new components underneath it. So that effectively meant that we had to do this work, but we had to do it sheltered, because it meant sweeping through the entire code base and making sure that not only just the core components, but all of the built-in applications which are in the same repository were upgraded as well, because we wanted to make sure we shipped it nicely, cohesively. Now, of course, this excludes any applications that companies may have outside of the ONOS code base. They'll have to do this work themselves. But we wanted to do this within the ONOS code base. And that work was going to take some time. So we did it actually on a separate development branch. But while we were doing it, other teams were continuing to work on the existing branch. And you see the results of their labor on the floor in the demos, right? Because a lot of these are, some of them are built on 2.0, but most of them are built actually on 1.14 or 1.15. And so, because this spanned like 8 weeks, there was still some work done on the old branch. And so we had one release cycle, but we effectively have 2 releases within that cycle. And so the release 1.15, that's the Peacock name, effectively comprises of work that was done while the upgrade was happening. So that's still sitting on the old Karaf, still sitting on the old Java. But we wanted to capture that work and kind of publish it as a it's kind of like punctuation at the end of a sentence of the 1.0 work stream. And that was released actually just last week or 2 weeks ago. Now, ONOS 2.0, we actually don't have an official name. Because we generally run a polling, like a naming poll in the beginning of a release. Peacock was voted in, but we didn't realize that we were going to have two versions, and so we still have to name the 2.0 version. But that's basically the first release that's going to have 4.2.1, Java 11, and moves forward. And also that's what carries all of the backwards incompatibilities. But speaking of those incompatibilities, we expect, even though it was a little bit of a pain because we had to do some research on the platform team to figure out how to do the upgrade. We provided a document that describes what needs to be done in order to port applications to the new version. And we're hoping that will be actually relatively minor for applications lying in external repositories. And of course, the release of this is still expected to be on the original timeline of the original Peacock release, which is basically in about 2 weeks time frame. For all practical purposes, we're in code freeze phase, so we just running through tests and fixing defects and things like that. So I don't expect there to be a delay. So basically, it'll be ready in just about 2 weeks. So that's roughly kind of where we are. But it's it's time to start looking a little bit ahead. So with the existing architecture that includes ONOS 2.0, we have some nice things. We've built some nice things over the years. So we have stable platform with a lot of apps, with easy SDK to develop new applications. It's easy to deploy as a standalone node or as a clustered node. We have integrations with Docker containers. We can still orchestrate it using Kubernetes. It's super fast because basically service invocations are effectively just method calls inside the JVM. So it's good. We feel pretty good about it. It's starting to enter productions. That's great. But we also are aware of some limitations that it has. And that's kind of like a two-sided coin. Some of the things that are responsible for the benefits are also responsible for some of the limitations. So for example, the fact that we're running inside the same JVM, which gives us lots of benefits, also has some caveats in the sense, for example, we don't have adequate isolation between the core and applications. They share the same resources, which makes it difficult to scale horizontally services or applications. It also makes it impossible really to have tenant-specific apps. You can have tenant-aware apps, but not tenant-specific apps. It's also difficult to write logically separate functionality and then physically separate it to actually post it on a switch. Because in some cases, and as you probably heard throughout the different talks in this conference, it would be good to have kind of fluidity to develop apps and actually host them different places. It's difficult to do that with this. And so we figured with the ONOS 2.0 providing a nice platform refresh and stable place to host functionality for several years down the road, now might be a good time to start looking at building basically kind of a new platform, taking advantage that we're in a really good spot with the existing one. Because last thing you want to do is wait until the other one starts to age, right? We want to kind of do things ahead of time. And so, so that's basically the goal, is to take advantage of where we are, also start looking at merging our efforts with the UPAN project, UPAN RD, because Stratum is making headway. It's just starting to get off the ground as basically a data plane for UPAN project, but we don't effectively have a control plane for the UPAN project. And so ONOS Next Generation can effectively slot into this. And the idea is to start doing this completely in the open right from the get-go with the help of the ONOS community. It's actually doing it even more open than what Stratum is doing. There's some reasons for the way they're doing things. Now, of course, that doesn't mean we're abandoning this existing platform. We will still continue to maintain the existing platform, fix defects, run through release cycles to make sure that this continues to be a vibrant and viable platform for several years down the road. But the time to start building the new office building, so to speak, to use the Comcast metaphor here, is now, so that it will be ready, let's say in a year's time frame for people to start considering moving across. So that's kind of where we are. And so how are we going to build a new building? Well, I don't know. Like I said, we're just starting on this, right? So we're going to figure it out together how to build a new building. But there are a few things that we know we want to preserve, and some architectural tenets about building this. We want to build it around open interfaces. That starts with gRPC, that starts with GNMI, GNOI, open config standard models that would be traveling over those interfaces. We want to build it around microservice architecture, so that you have great elasticity with where you host pieces. This will also enable us to develop some functionality actually hosted, embedded on a switch if it's desirable for the particular deployment. We also want to divest in some of the functionality that we had to do in the past. For example, we have what I feel is a great application management subsystem that allows us to drop an application on one node and it's instantiated across all the nodes. That's great in today's ONOS, but if there is an open source software that allows us to do that, and in this case we can probably build on Kubernetes and Helm charts, we don't need to reinvent that wheel. Right? So the idea is to reevaluate the landscape of open source software today and start taking advantage of it. Because remember, a lot of these things were not there when we started the journey with existing ONOS. So we're basically just reestablishing where things are. Now, of course, that doesn't mean we're going to throw all our existing code away. It means we're going to reuse it as appropriate. You know, all of the work that's being done on the UI too, we intend to reuse it. It may not be looking exactly like this, but majority of the work and the framework that was being developed by Sean is going to be carried forward. Similar things with all of the advancements made in Atomics are going to be carried forward. And this is just some examples, right? So the idea here is to also, from the get-go, to focus on use case-driven development. Develop only those features that are required for specific use cases, and for specific deployments. Now that doesn't mean that others can't build other things. You know, it can still be used as academic project, it can still be used for other things, but we want to make sure that it's oriented from the get-go to enter production. And of course, last but not least, we want to allow components to be written in different languages. You know, today we're kind of stuck with this. So, okay, so that's really all I have. I mean, this last slide captures the state of kind of mind that I have. So everybody knows what we know, and you're welcome to join us on the journey and build the new platform together. And I definitely encourage you to start to do that. We will be loading our TST meetings with discussions about this, and this will definitely be joined in some way with a UPAN RD work group as well. So as a start of new year, I encourage you guys to join the effort and let's build this together. So with that, let's make it so, engage. That's all I have. How are we doing on time? Do you know? Okay, good. So is there any questions or kind of blitz through? Yes, Angelos?
So the document you mentioned for the transition to 2.0, will it be on the wiki page?
The document?
Yes.
You know, I don't know if it's on the wiki page. We had sent it in.
It's a Google Doc.
Yeah.
Currently, it went out to the ONOS mailing list.
Right.
Okay, so
We should definitely link to it. On the wiki
Yeah, and it's also on one of the TST meetings linked in as so on a TST page, but we should definitely put it on the wiki page.
Okay, perfect. And one more question, if I may.
Mm-hmm.
For the ONOS 3.0 or however it's going
Next
to be
gen,
called.
we'll probably break off the version numbers and start new.
So it's going to be, instead of a single JVM, it's going to be a Kubernetes pod or something? Like the idea is to move that way, right?
So it's going to be, like I said, it's going to be microservice based. So most likely there will be something, at least one service, if not a constellation of services that will provide kind of the networking core, kind of the basic minimal set of services to provide situational awareness for applications, to be able to ask questions about topology, be able to be notified when topology changes, to be able to do that sort of the minimal stuff. Will probably be, whether it's one service or multiple services, I don't know. That, again,
but
you know what was on the slide before, right?
The individual labs are going to be different containers?
That's the idea,
okay.
Yes. So southbound, generally, let's say, just as an example, I mean, again, this is just spitballing. While I'm not hesitant to expose us to gRPC and GNOI and GNMI because those are kind of considered now open interfaces. I'm still reluctant to expose us to OpenFlow directly, right? Because in the past, we've almost benefited greatly for kind of encapsulating the southbound protocols, whether at the time OpenFlow was the leading one. It doesn't really matter whether we were fans, we still benefited from OpenFlow being encapsulated and hidden. because it allowed us to move to different versions of OpenFlow without being subject to changes in the libraries, and also allowed us to look back and actually develop adapters for legacy protocols. And also that's what enabled, that same approach enabled us to look forward in the future and actually develop stuff for P4 and P4 runtime. And that stuff was not even anywhere on the horizon when we were developing ONOS, and we still benefited from that approach. So most likely we will still follow that level of, so that's some kind of encapsulation so that we're not subject or tied or victimized by a specific protocol. But I don't have a problem getting directly tied to a generic RPC. Just I don't want to be tied to a specific network related protocol. That would be bad in my opinion because things change in that realm. Yeah. Hopefully that answers your question.
Do you want to talk about configuration store and dynamic configuration service? What are the problems and what are the new changes probably coming?
So is your question oriented for the existing architecture for looking ahead? I just want to make sure I answered the right question.
What were the problems with one architecture and what would be kind of?
Well, so first of all, you can do configuration just fine with the existing architecture. This whole notion that you need a dynamic configuration or whatever the subsystem was called, it's nonsense. You don't need it. You have driver subsystem, you can exchange open config Yang models or whatever are the Yang models that you want as a way of interacting with other things. But it's not predicated on having a system-wide Yang related store like MD-Cell. That's nonsense. You don't need that. Now, there was a project, one of our partners kicked off to be able to build such a thing, but that project stalled. It went through kind of a second wave of DCS 2.0. That also stalled. The core team is not big enough to develop it. We don't have an immediate need to drive to develop it, so people are certainly welcome to develop it if they want, but it's not a necessity in my view. Being able to configure environment is absolutely necessary in my view. But just that particular way of going about it is not. That's just one way of going about it. ONOS 2.0, ONOS can do it today. Next gen ONOS will be able to do it, and there will definitely be very heavy reliance on open config and other kind of open ways of configuring and provisioning environments. Control alone is not enough, right? You need to be able to manage it, you need to be able to monitor it, you need to be able to control it. That's all part of the same plane in my view. And so all of those things are clearly very important. But the DCS is just one way of doing things, and it's not necessarily the only one, nor necessarily the best one to do it. Is there any other questions? Yes?
Do you have a timeline for the next generation? Did you?
Nope. So the goal is, though, at least it's kind of in the back of my head, is the idea is to do it in an agile way. Just pick a couple of use cases, start driving towards it, build it incrementally, I would hope that we would be able to demonstrate some seeds of this effort at ONS.
Okay.
However small they may be, it might be very small.
Yeah.
But then, every 3 months or so, demonstrate something and just keep going.
Okay.
I would like to avoid kind of a big black hole period where nothing happens, because the world changes, and if you don't react to it, that's bad. Yes?
Thank you. Oops. Are there scale targets in the 1.14 and beyond into 2.0 where Trellis and then evolution to Stratum are concerned, given, as you mentioned, the production deployment at 1.12
Yes.
exists today, and how that will evolve in scale terms?
So I'm not sure how much I can talk with respect to the specific production deployment. You would have to ask our fellows from Comcast specifically what their targets are. But it would be fairly high in terms of number of flows and number of routes. The idea is to carry that forward for next generation clearly and do better even. right? And so some of the improvements that we made, so I can talk about specifics. For example, the 12, version 12, there's one particular, the flow rule store specifically, replicates basically the entire table as a single bucket. So we need to be able to replicate it and make sure that other nodes other than the current master has a copy of it, so that if there's a master ship swap over, that the new flow tables are available on the kind of the secondary slaves, which may potentially be future masters. But because it replicates as a whole chunk, if you have, let's say, 100,000 flows in one table, that takes a while and actually was causing these spike loads on the intra-cluster traffic. And so one of the enhancements that was made in, I think, was it 113, Jordan? I don't know, maybe 113 or 114. I'm sorry? 113. Yeah, so we actually bucketized it. We segmented the flow table into buckets and replicate on per bucket basis. And so they made things much smoother. And so that's one of the reasons that Comcast is actually looking at the later versions as an evaluation for this. And we've encouraged them to actually jump straight to 14, because in addition to having that optimization, there were other improvements made in 14. But you will have to ask them about specific goals for that. I don't want to.
Oh, thank you. Thank you.
Yes. Thanks. I think there was just time. He was giving me just we have 4 minutes. So we still have some time for questions, if people have questions. Yes.
Are we going to continue work on atomics to improve it? Basically, we find out in our deployments for high availability scenarios, like we in our labs, we find that when we delete one of the node and the replication or restarting has certain issues pertaining to atomics. So are we continuing to put our effort on atomics?
So atomics exists as a separate project. It's actually used in open source projects outside of ONOS. And it actually started completely separate from ONOS, right? ONOS kind of, as part of doing development, the distributed development, we actually stumbled on atomics and Copycat at the time. So it'll continue to maintain its independence, and it'll continue to be maintained. About the specifics of the issues that you're seeing, you would have to talk. I'm going to ask you to ask the question to Jordan, who's going to be following. Is actually going to have 2 opportunities to do that, one in the following session and one in a session at, I believe, 5 o'clock. So, but definitely investment in atomics will continue, because at least to the best of my knowledge, we don't see anything like that out there. I mean, you have etcd, you have console, but they have their own specific issues, and I don't think they're necessarily a good fit for what we're trying to do here.
So how do you guys do testing? How do you go into, for somebody to be production ready? How do you, what's your strategy?
ONF is a small, that's a great question. Now, ONF is a small organization, so we do have our own QA group, actually, and we do QA some features that community develops as well, though not necessarily in a laser sharp focus. It's kind of maybe incidental testing. But because we're a small organization, we don't really have the resources to do full hardening and full productization that may necessarily be expected, from companies like Red Hat or IBM, right, or whatever. However, we still try to do test-driven development, so we have high coverage in unit tests. We also have developer-oriented scenario testing that's available for all developers. They can run basically a suite of system-level tests on different environments. And in addition to that, we have a much deeper set of QA tests that measure for regressions, both in terms of functionality as well as in terms of performance. Now, performance, we have tests for scale. We're starting to, but I don't think we necessarily have the resources to be able to do this scale. Especially because there are different environments will scale along different dimensions, right? If you were to look at the Comcast deployment, for example, not that many devices, but maybe lots and lots of routes and flows. But in some environments, it may be completely opposite. Maybe lots and lots of devices with very few flows here. So it's difficult to figure out how to scale things. We just want to make sure that the system itself presents as little kind of internal resistance performance-wise as possible, and then it allows to be scaled kind of horizontally. And
reference labs that you place them into? Like does operator provide you with reference labs?
no, I think they have their own internal testing. I think Comcast and InfoSystems run their own tests on their own. I mean, we have some visibility to what the results are when things, for example, don't turn out, you know, they come up with some issues, then we are exposed to that, but they're the ones who are operating those. So I think we have room for, that's it, I think. So
One more question, maybe?
if there's one more question, it's fine, but if not, we can probably move to the next speaker. All right, well, thanks.